Oh, hi, I'm Steve Weavers, creator of the Imaging Whiteboard. In this video, I'm going to look at the FFT control and frequency domain processing. Here I am at somewhat lower resolution than usual because I'm running a 128 by 128 FFT and reverse FFT on a live image, and we're pretty close to real time here. Not bad for an FFT. Later on in this video I'm going to use 512 by 512 and you'll see the processing rate will slow down a bit there. But for now, let's just look at some of the things we're doing here. Okay, as I said, we have selected 128 by 128, but this is from a 320 by 240 image. Now, what happens when the FFT size is smaller than the image is the FFT will just be performed on the center part of the image. So we're doing a two-dimensional FFT, no window function. The mask operation is off now, so we can see that we've just reconstructed the image, and that's what you can see. And if we look at the FFT mask there down here, we can see we've just put the mask around the very lowest frequencies there. So if we click the include button, you should be able to see that we just get the low frequencies through, and we've got a very blurry image. If we click the exclude, we can see that just leaves us with the high frequencies, and we can see that in the image. Can turn up the output gain, just make it a little bit more obvious. So that's pretty much it for a basic FFT. I'm just going to pause, and then we're going to start looking at some test patterns and some larger FFTs. Hi, now we're back here with, instead of the camera input, I've now got the test pattern input, and I've picked Lena. And I've got the repeat on, so we're repeating the frame so we can, a little bit easier to demonstrate things. And pretty much left it where I left off, except that we've now got a 512 by 512 FFT, so we can see that the FFT itself looks bigger. Again, I've just masked off the low frequencies, and let's go back to taking the mask off altogether. So we can see here the full resolution. Every frequency in the original image has come through. If I just include the low frequencies, as you can see, you get a slightly blurred image. If I exclude the low frequencies, again we get the high frequencies, and I'm going to just up the output again just to make that more obvious. So we can see just the high frequencies of the test pattern there. Okay, now what we can see here is the mask we can change. So if we make it somewhat smaller, we should get slightly more out. Some bigger, should get somewhat less out, and so on. We can do weird things. We can put it asymmetric here, which is slightly odd. Let's turn that down. We can do other things. We don't have to have square masks. We can just put a vertical on there to show more of the vertical edges. We do it horizontally the same here. Kind of get some more horizontal edges out there. But none of this is ideal. What we really need is just a circular exclusion zone centered on the middle of the FFT, and I'm going to pause and bring that back up. Okay, so here we're using the same test image, but we have two FFT controls. So the first FFT control is doing the forward FFT and displaying the output here. The FFT control, apart from output in the reconstructed image will also output the FFT results. And what we can do here is using the gate control, and I've set that up with circle include, and the circle size I've set here, that can be changed. And we can see on the second FFT control what we're left with. So we're just left with the center part of the FFT here, which has left us with a slightly blurred image. I think I'm going to decrease the size of the circle to make it slightly more blurry, just to be obvious. Okay, and there, that's achieved that. Now, if we want to change that to exclude those frequencies, we can click the circle exclude. Okay, we can see there we've got the FFT except the circle there, and again we've got the high frequency output here. Let's again turn that up to make things a bit more obvious. So that's obviously preferable to just the rectangular and perhaps slightly misplaced filters that you can do with just a single FFT control. Here we're doing something similar, except that we've got two gate controls. The first one's doing an include and the second one's doing an exclude. We can see what that leaves us with is effectively a bandpass filter with this result here. Also, I've included the set memory control up front so that we can compare the result with the original. So if we take a look at the original here, okay, and we can also see a split view to get both. Okay, in this whiteboard, I'm actually combining the high frequencies with the original FFT in order to do some image sharpening. So we can see here that we have an image combine control, and we're combining the original FFT from the forward FFT, and we're combining it with the gated FFT from the forward FFT through the gate control with the circle include. In the second FFT control, we can see the result of this. We can see that the high frequencies have been added in, and we can see this bright, fairly large circle to indicate that. And here we can see the sharpened image. In this final whiteboard, what I've done here is combined the FFT results of two separate images. So the first image is a face shot of Jane Russell, and I'm passing that through an FFT control and also through a circle include control to produce a low pass filter. And similarly, the image of Tony Curtis, I'm passing through a high pass filter, so we've got another FFT control and a circle exclude, and then I'm adding the results of the two images. I've kind of tried to go some way to reduce the complexity of the whole thing here by putting the two forward pass FFTs into their own separate sub whiteboards, and we can see the result here. The include result for Jane Russell is slightly smaller than the exclude circle for Tony Curtis, so we can see a slight black ring around here which actually separates the two results. And when we sum the FFT results and perform the reverse FFT, what we see here is a combined image. If you're looking at this image from a distance or in low resolution, you'll see the face of Jane Russell. If you look at it in high resolution, close up, you'll see the image of Tony Curtis. This is some indication of the way that the visual cortex works.